What I want to talk about is a tool, and the tool we are mainly developing with people at the University Carlos III de Madrid in Spain. And I should actually mention that the work actually has been done by Andra. She has done all of the work, so the credit will go to her. But she has a important other meeting in Italy, so which is important for her PhD. So unfortunately, she can't be here. But yeah, what I'm going to present is a tool, and a tool which is hopefully useful, or can hopefully be useful for you. And we also would like to extend that tool in the future, and we would like to get your input, your feedback on how to extend this work. So that's why I'm here to present this. So Andra is doing her PhD on BGP, and BGP is obviously, with all the operational and economic and political factors, a complex protocol. So fair enough, she can do a PhD in this area. What we are looking here is on filtering. Obviously, when you announce your routes, they propagate through the network, and hopefully you will have reachability, ideally everywhere. But to know if you have reachability everywhere, or if someone is filtering you or not, especially for newly allocated address space, you need to rely on external sources like looking glasses and so on. And RIPE and RouteViews have done an incredibly job on providing those sources. What we have been doing is looking into understanding more the policies behind which are going on in the internet, what you can see from those public sources. So that was our main motivation. And we wanted to understand where is filtering going on, how is filtering being done, where are potential problems of filtering, and can we detect that just from those public sources. Obviously, the public sources, despite the fact that they are incredibly good, they only give you a little bit limited visibility into what's actually going on, but can we actually infer what is really happening? And so when you look at all those prefixes that you can see, you notice you have two types really. One prefix, which we call high visibility prefixes, which are just everywhere. But then you see also prefixes which we call limited visibility prefixes, which are not in every routing table all over the globe. So with all the data we have, about 130 different ASs data, and we would like to understand what is driving this limited visibility. So I'm going to talk a little bit about the methodology, give a little bit of statistics, data that we have found in the, and also at the end I will present one use case. Oops. Okay, that was a bit fast. So yeah, that is basically the idea behind the visibility scanner. We take the raw data from RIPE, from RouteViews. We then extract what we call the global routing table. We have abbreviated here with GRT, but this is a global routing table. Obviously, we are not interested in feeds which only give you like a peering feed on RIPE. You have often just like limited feeds. Then we clean the data a little bit, and then we have the main algorithm. So the raw data is being downloaded by the tool twice a day from RIPE and RouteViews. Then we, as I said, we filter the data. We are only interested in full routing tables, so which have 400,000 something prefixes in there. We remove duplicated feeds and so on. We clean the data, so no bogan routes and so on are in there anymore. And then we, so in this example, throughout the talk, I'm going to present the results from a study in October 2012. And so when we look here on this plot, for example, which shows on the x-axis the prefix length, on the y-axis it shows on a logarithmic scale the number of prefixes, so it's just a count, but it's a logarithmic scale, so it's emphasizing, like here you have 10, then you have 100, then you have 1,000, then you have 10,000, and so on. So, and in the different colors show the different kind of, on how many observation points you have seen certain prefixes. So the blue colors here mean that you have only seen the certain prefixes on a very few observation points, while the red colors mean they have been more or less seen everywhere. So what this should just illustrate is that there is a lot of prefixes in the internet which are only very regional. They propagate only very regional. And what we try to understand is, why are they limited in this visibility? Why do they not propagate everywhere? Obviously, that can have traffic engineering reasons, that can have many other reasons. But yeah, we would like to understand this better. Limited visibility, I should also clarify, doesn't mean that there's not a covering prefix which might provide still some kind of reachability. So this would be what we call dark address space, where we don't have any reachability to that prefix. But yeah, let's look into the algorithm a little bit. So we download all the data, then we filter out first internal roots. So internal roots are prefixes which just have an AS path length of 1. So they are clearly just originated by the AS, which is giving the feed to the to ripe or route views. So those are about 10,000 prefixes that we filter out first, but then we still separate them into these high visibility prefixes, which are 95% of all routing tables should see that prefix, or limited visibility prefixes, which have less than 95% of routing tables see this prefix. And the last bit of the algorithm then tries to filter a little bit further what are transient prefixes. So some prefixes could just occur for a short time and then go away. That might be something what is happening for some time. But others are really consistent over a long period in time present. So we are more interested in those which are constantly, permanently in the routing table, but do not propagate everywhere. And that can be either intentional or unintentional. And we would like to tweak our algorithm a little bit further by really distinguishing between those two cases. So just to clarify a little bit better, with limited visibility, we mean prefixes which might have a covering prefix, while dark prefixes will not have a covering prefix. So, but still, we see in the routing tables about 2,400 dark prefixes which do not have reachability from all the places. And what we would like to understand is, why is that happening? Here I have just a slide which shows the, just a histogram of the prefix length distribution again, but this time separated by high visibility, which propagate everywhere, which is more or less a normal prefix length distribution, as you probably have seen it many times on whatever, Geoff Houston's website. And then limited visibility prefixes and dark prefixes. So not surprisingly, anything beyond a /24, like longer 25 or longer, has no high visibility. So that is not surprising. But what was actually surprising to me initially when I saw the data for the first time, that we still have quite a bit of limited visibility prefixes and so on, with quite large address range, prefix lengths. Also, when we look at the AS path length distribution, on this plot we show on the x-axis the length of the AS path at the observation point, and we see that limited visibility prefixes not necessarily travel as far, but dark address space and high visibility prefixes can actually travel quite a long time. So we would really like to understand a little bit what is going on. This is just an illustration of on how many monitors you see how many prefixes, like just a histogram again. On the y-axis, logarithmically, the number of prefixes. On the x-axis, the number of monitors. In yellow is the high visibility, or 95%. And and this more or less just illustrates that we can have all kind of distributions here. So some limited visibility prefixes just propagate through half of the network. So they also appear to be fairly stable over time. So they don't just appear or disappear. So in the final stage, we really look at those which are stable a long time. So what we have found is about 3,500 ASs which have those limited visibility prefixes. And again, that could be on purpose, and we would like to learn more about why that is. Or that could be accidental. So we have also found ASs which were not aware of the fact that they had limited visibility prefixes. In this case, the tool what we have developed might help actually of detecting those problems. So the tool is at visibility.it.uc3m.es. It's also on the website. A link is on the website. And if you go to that website, you can just put in your AS number here. You get a list, if you have any limited visibility prefixes in your network, what we have found. You get a list of your prefixes which we have found. And then you have a feedback form which where you could tell us what kind of prefixes they are. So we ask a little bit a few questions there. For example, are you aware that they are limited visibility prefixes? Or did you intend that they are globally reachable, or should they have been only maybe staying inside the AS and not been leaking outside? Is that accidentally leaking, or is that intentionally propagating? And you can also add some comments. So we would appreciate a little bit feedback here, so that we can understand better what is the cause of those limited visibility prefixes. So I would also like to give a little bit of some use case studies that we have found so far. So, for example, scoped advertisements, traffic engineering based on prefix length can be very much like a source of limited visibility prefixes. However, if you have some filtering going on, especially for newly allocated address range, you might notice that prefixes do not propagate through the whole network, so you have actually no reachability potentially, which would be dark address space. And there are tools out there, a few, which already look into this one. For example, Cyclops at the university, UCLA, and so on. There are many tools, but as feedback, what I would like to receive is, are you interested in those tools, and would you use those tools? One of the interesting cases that we found was a story from the root, from one of the root name servers, which were trying to do some anycast, and they were creating limited visibility prefixes on purpose. So, for example, here we have the root server, and they're doing anycast. So they're giving at the exchange point their prefix, which is a /24, to a peer. At some exchange points, they get from one or two ISPs a full feed, but at others, they don't get a full feed. So what happened was that if they don't have a full feed, you don't have a return pass if the prefix leaks on. So obviously, they have all the prefixes received from the peer, but if the peer actually leaks accidentally the prefix, then the second peer might send traffic towards the root server. It reaches the root server, which is good, but the root server then doesn't have a pass back towards that address space. So what they did, and this leakage was obviously not intentional, but it happened actually quite a lot of time. So what they did is they announced the /24 on all those local places with a no export community set, which obviously doesn't export then the prefix to the peer. So the problem is solved, right? Well, not quite, because if you put a no export on your root, it doesn't even go to your customer. So it was not supposed to leak to the peer, but it also didn't went to the customer. So what they are now doing is they have a root server base camp, which announces a prefix that comes in via the transit provider and works almost like a magnet, or it's actually a /23, which works almost like a magnet. So it gets filtered by the no export, but the /23 propagates through, and when the traffic from the customer is being attracted by the /23, it reaches the peer, but then turns around and goes via the more specific to the right local root name server. So that is one of the cases, of those use cases, that we are currently looking for intentional limited visibility prefixes. And to understand more why we have such a high number of limited visibility prefixes in the internet, we would like to hear few more of those use cases from you. Maybe not in the open, but maybe via the feedback form or via email. That would be really interesting to us to understand what is going on there. Just to conclude, this is just showing a log about limited visibility prefixes. And by that time, where our tool was operational and we found the first cases, we also saw that there were some errors actually in the data. So we contacted the operators, and they actually found that it was unintentional and removed those limited visibility prefixes from the routing table. So the number actually went down. But yeah, this concludes my talk. And I would be very, very happy if you would try out the tool and give us a bit feedback on the tool.
Thank you, Olaf.
Thank you.
Any questions for Olaf? Or comments or feedback? Okay, thank you.
Thank you.